Hello. This is a very short video that will help you answer the questions of Lab 5. And it's about the audiograms that are related to the heart sounds and murmurs. The topic we discussed in class. This is like an extension to what we said in the classroom. Now let's move on to the first slide. Here, for example, these are different audiograms of different kinds of murmurs. For example, concerning aortic stenosis, you know that in aortic stenosis, the aortic valve is a narrow valve, and therefore, while the left ventricle is trying to pump blood into the aorta through the aortic valve, the blood will flow through a narrow valve that has a smaller diameter than normal, and therefore there will be an abnormal sound that will be superimposed on S1 and S2. And since this sound is heard while the left ventricle is pumping blood into the aorta, then it would be best heard on the aortic area, which is the second intercostal space to the right of the sternum, or at the right sternal edge. And if I ever ask you to draw the audiogram of aortic stenosis, it is a very specific and characteristic audiogram. But first, let me tell you what an audiogram is. If we split the word, so it's a diagram that that includes a sound, or it is a diagram that represents the sound we hear. How would it represent the sound we hear? It would, first of all, represent the timing of that murmur, and number two, it would represent the changes in sound intensity as the murmur proceeds. If we apply this, for example, to the murmur of aortic stenosis, then the audiogram for the murmur of aortic stenosis would represent, first of all, a systolic murmur, because we hear the sound during left ventricular systole, while the left ventricle is contracting and ejecting blood into through the stenotic aortic valve. Number two, so since it is a systolic murmur, first let me proceed and elaborate on this. Since it is a systolic murmur, then it would be located between S1 and S2, because S1 is due to closure of the atrioventricular valves at the beginning of systole, and S2 is due to closure of the semilunar valves at the beginning of diastole, and therefore this time duration between S1 and S2 is systolic. And it is the audiogram of aortic stenosis. Let me tell you that it is a very characteristic one, because it is diamond shaped, as you see. It is diamond shaped. So if I ever ask you to draw it, you have to draw it like a diamond. Of course, these what you see, these shapes are nothing but the changes in sound intensity, and the systolic murmur is diamond shaped, meaning that it has a crescendo part, and by crescendo we mean that the intensity is increasing, and it has a decrescendo part where the intensity is decreasing. And the murmur of aortic stenosis is very characteristic because, of course, it will be best heard over the aortic area, the second intercostal space to the right of the sternum. But some murmurs are characterized by their ability to radiate, meaning that they can be transferred to other areas where you still can hear them well. And aortic stenosis radiates upwards to the neck, and it might be confused with what we call a carotid murmur, because here we have a very important artery, the carotid artery, that carries blood to the head and neck. And if the carotid artery, for a reason or another, is narrowed by cholesterol and atheromatous plaques that narrow, and of course this is something very dangerous, because these atheromatous plaques or cholesterol plaques, can be fragmented and go to the brain and obliterate blood vessels in the brain and cause a brain stroke. But you have to make sure that what you hear here on the carotid artery is not a real carotid murmur, but it is radiated from the systolic diamond-shaped crescendo decrescendo murmur of aortic stenosis. How are we going to hear this crescendo decrescendo? First of all, it is systolic, meaning that it is between S1 and S2. Second, the murmur will be low at the beginning, and then it will increase in intensity, and then it will decrease in intensity. In case, for example, of mitral regurg, of course, you know that in case of mitral regurgitation, the murmur is systolic because it occurs during contraction of the left ventricle and regurgitation of blood through the incompetent valve to the left atrium, as we have said several times. Here the murmur is between S1 and S2, meaning that it is a systolic murmur, but when you draw the audiogram, you will not draw it as you did in aortic stenosis. It's not crescendo decrescendo. It has the same intensity throughout systole, but it is worth mentioning that whatever murmur that includes the whole time duration between S1 and S2 will be called a hollow systolic murmur, a hollow systolic murmur. So the murmur of mitral regurg is a hollow systolic murmur. It includes or it covers the whole time duration between S1 and S2, just like the murmur of aortic stenosis is includes the whole duration of S1 and S2. But you will best hear it in the middle of the duration, time duration between S1 and S2. That's why you might consider it a mid-systolic murmur, because the maximum intensity occurs at the middle of the distance between S1 and S2. In case of aortic regurg, of course, you all know that aortic regurgitation occurs because of an incompetent aortic valve, meaning that when the aortic valve wants to close at the beginning of diastole, when the left ventricular pressure diminishes, it does not close perfectly, and there is some leakage of blood that occurs from the aorta into the left ventricle during diastole, and it is that leakage of blood that causes this murmur during diastole. You see here it is between S2 and the next S1, so it is a diastolic murmur, and as you see, it is a purely decrescendo murmur, meaning that it starts with a high intensity and then the intensity diminishes gradually. So you will best hear it at the beginning of diastole. So it includes the whole duration of diastole, but the maximum intensity is early diastolic. Okay. Here, for example, this is the very famous murmur of mitral stenosis. We have listened to the murmur of mitral stenosis in class last time when we were at school, and you all know, of course, that the murmur of mitral stenosis is a diastolic murmur, because the problem in mitral stenosis is that when the blood tries to pass from the left atrium to the left ventricle, and this definitely occurs during diastole, it will pass through a narrow mitral valve. And when blood passes through an opening or an orifice that has a smaller diameter than normal, it will produce an abnormal sound or a murmur. The cause of a murmur is always either blood passing through a smaller cross-sectional area, or an increased flow of blood, or the flow of blood in an opposite direction. So we have multiple causes for a murmur. So it's always something abnormal about blood flow. So it is an abnormal blood flow either because it passes through a smaller a cross-sectional area, or because we have more blood that passes through the original area, more blood that tries to pass. So the problem in this condition is not in the valve. It's not the valve that is small in area, but it is the flow that is increased. So it would be a relative stenosis, because relatively the blood that passes is more than the capacity of the normal area of the valve to accommodate the blood. And the third cause is the backflow, when some blood backflows or regurgitates. So it is it's passing in the opposite direction of the normal traffic of blood, and it causes a murmur. In case of mitral stenosis, the problem is that the cross-sectional area of the valve is small, and we hear a diastolic murmur. But that diastolic murmur is essentially a mid-diastolic murmur. So you hear lub-dub, which is the normal time duration between the first and second heart sounds, and then there is a pause, lub-dub, lub-dub, lub-dub. And in this pause, it will not be a clear pause. There will be a murmur, but that murmur will not be heard at the beginning of diastole. There will be a very small time lapse, and then you will start hearing the murmur of mitral stenosis. And there is two other very important characteristics. Maybe if you focus while listening to the mitral stenosis murmur, or if you use the audio at a lower speed, you can distinguish these characteristics. First of all, since it is a diastolic murmur, it occurs between S2 and the next S1. So what you will notice, if you have a smaller speed, if you listen to a smaller speed or a lower speed of the audio, you will find that at the end of diastole and just before the next S1, you will find an increased intensity, or an augmentation of intensity of the murmur. And since it occurs just before the next systole, we call it a pre-systolic accentuation. Of course, at the beginning, for beginners, it would be great if you hear the mid-systolic, the mid-diastolic murmur, but later on, you will notice that you can detect the pre-systolic accentuation, okay? The second characteristic is the opening snap, meaning that after you hear this S2, so you hear lub-dub, and then a gap, and then another sound, which we call the opening snap, and it is usually due to the calcification of the mitral valve. In case of mitral valve prolapse, it results in mitral regurgitation, meaning that every time the mitral valve should close at the beginning of left ventricular systole, one of the flaps of the mitral valve will bulge upwards like this because of the increased pressure in the left ventricle. And when it bulges upwards, you can never guarantee that it will close perfectly, and some blood will leak, resulting in mitral regurgitation. Most of the time, mitral valve prolapse or bulging of one of the cusps of the mitral valve into the left atrium is a mild condition It's very common in Egypt among people, and most of the time the patient is asymptomatic or just shows symptoms, for example, when he stands up suddenly or when he squats, but most of the time the symptoms are very mild. But if mitral valve prolapse becomes more accentuated, the patient will start suffering of symptoms. Of course, it is a systolic murmur. There is a click at the beginning, just like the snap that occurs at the beginning of mitral stenosis. But here the murmur is systolic, and it is a late systolic murmur, as you see. It is a late systolic murmur, and it has the same intensity all throughout late systole. After sudden standing, you can see that the murmur is still there. It is still systolic, but it is longer in duration. It almost takes the whole duration of systole. But after squatting, it is in late systolic murmur. Of course, I'll never ask you about these two conditions. It would be great if you know that mitral valve prolapse occurs in late systole and is preceded by a click. In case of pulmonary stenosis, of course, pulmonary stenosis means that when the right ventricle starts to pump blood into the pulmonary artery, it would find a stenotic valve that has a lower surface area, and therefore we will hear a murmur, and the murmur is like the murmur of aortic stenosis. It is a crescendo decrescendo murmur. Sometimes we say diminuendo, meaning a diminution or decrease. It is diamond-shaped again, and it is a systolic murmur. But here you can see something. You can see a split second heart sound. And in that split, we said before in class that the split second heart sound, or the split sounds in general, means that the two valves do not close at the same time. The two valves do not close simultaneously. The two valves do not close simultaneously. And in such a case, you can see that it is the aortic valve that closes first. Why? Because the aortic valve is supposed to be normal. The left ventricle doesn't find any resistance in pumping the blood into the aorta, so it receives all the blood, closes, and starts its diastole, or the left ventricle starts its diastole. But in case of the pulmonary valve, since it is stenotic and the right ventricle is trying to push blood against this high resistance of the stenotic pulmonary valve, so definitely the right ventricle would take a longer period of time to eject all this blood or the volume of blood that is supposed to be pumped and ejected into the pulmonary artery. It would take a relatively longer period of time, and therefore the right ventricle will start its diastole, and the pulmonary valve would start its closure after a bit or a while after the aortic valve. You can see that, again, this is just for your general knowledge, case 2 and case 3. As the severity of pulmonary stenosis increases, you can see that the murmur starts to have a longer duration of time. In case of pulmonary regurgitation, of course, this is leakage of blood at the beginning of diastole, and that's why we can see that we have an early diastolic murmur, just like in aortic regurg, we had an early diastolic murmur. And as you know perfectly, the only difference would be in the location. If I have aortic regurgitation, it would be an early diastolic murmur. If I have pulmonary regurgitation, it would be an early diastolic murmur. But the first one, the aortic one, would be heard in the aortic area, whereas the second one, the pulmonary one, would be heard in the pulmonary area. As we said again in class, in case of atrial septal defect, if I have the right atrium and the left atrium, and I have a hole here, then a hole, H-O-L-E, because the interatrial septum hasn't sealed perfectly during intrauterine life, during embryonic development, then because the pressure on the left side is higher than the pressure on the right side, then the blood will pass from the left atrium to the right atrium. But this is not the murmur we hear. The murmur we hear, because we focus on the major auscultatory areas, if you push more blood to the right atrium, then the right atrium will deliver more blood to the right ventricle. It makes sense. And the right ventricle will pump more blood into the pulmonary artery. So even if the pulmonary artery has a normal cross-sectional area, yet the increased blood volume will give you a sound that is similar to pulmonary stenosis, because here you have a relative pulmonary narrowing, not because the pulmonary valve has a smaller cross-sectional area, but because there is more blood that is passing. So in case of atrial septal defect, you will hear a murmur that is systolic, that is diamond-shaped, that is crescendo, decrescendo, very similar to the murmur of pulmonary stenosis, and it is best heard over the pulmonary area, although the defect is in the interatrial septum. In case of, we talked about the split S1, split S2, when we were talking about pulmonary stenosis, and now we can see here a split S sound, S1 or first heart sound, simply because the mitral valve and the tricuspid valve do not close at the same time. And this is how, it's a very simple audiogram. This is how we draw the audiogram of a split S1. Thank you so much. I think this is enough information for you to answer the questions of Lab 5 that will be uploaded soon on Google Classroom, and see you inshallah next Tuesday at school. Bye.